Hello, my name is Pranjal Kashpia, an AI engineer at IPCS Global Nagpur. I hold a post-graduation degree in computer science and artificial intelligence from IIIT Delhi. I'm passionate about the helping working professionals and also students to grow in the field of data science and artificial intelligence. So in this session, we will be diving into the world of YOLOv11, an advanced computer vision model used for the object detection. So whether you are a beginner or the experienced professional, this video will provide a valuable insight into the how YOLOv11 works and how you can leverage it for the real world applications. So throughout the session, I will guide you through the important concepts and applications and the practical tips you need to get started with the YOLOv11. So let's learn and grow together in the exciting world of AI. I hope this session helps you to take the next step in your career, and stay tuned. Let's get started. So we will explore how YOLOv11, the latest iteration of You Only Look Once algorithm, is setting a new benchmark in speed, accuracy, and efficiency. Additionally, we will dive into the practical aspects such as setting up the environment and running interfaces and understanding the real world application of this cutting edge technology. So let's get started on this exciting journey into the world of computer vision and the object detection with YOLOv11. I hope you will find this session both informative and engaging. Stay tuned till the end for the quick hands-on challenge to test your understanding. So firstly, we will cover a quick introduction to the computer vision. Computer vision is a field of artificial intelligence focused on teaching machines to interpret and understand visual information from the world, much like humans do. The goal is to enable machines to process, analyze, and make decisions based on the images, videos, or the visuals input. So key applications of computer vision includes object detection, identifying the locating objects in an image or the video. So it is called as object detection. Image segmentation, dividing an image into the segments so you can simplify its analysis. Also facial recognition, identifying or verifying individuals based on the facial features. Also the application of computer science in autonomous driving. So if I talk about the autonomous driving, enabling vehicles to navigate and make decisions by understanding their environment. So these are the technologies that having a real world impact by driving in automation, improving analytics, and enhancing the accuracy of system across the industries, from the healthcare to security to transportation and retail. So the application of computer vision so widely, it is spreading out all the sector in all the services. So what is YOLO? YOLO stands for You Only Look Once, a powerful real-time object detection algorithm unlike traditional object detection methods, which often require multiple passes over an image to make predictions. YOLO performs object detection in a single pass, making it highly efficient and fast. So the key feature of YOLO is real-time object detection. YOLO can detect objects in an image or the videos with minimal latency, enabling it to be used in applications requiring the quick decisions. Second feature of YOLO is single pass image analysis. YOLO processes the entire image at once, making it much faster compared to older methods that scan images multiple times. High accuracy and the speed. So if we talk about the accuracy and the speed, by using YOLO, the architecture of the YOLO is unified. YOLO achieves the both high accuracy in detecting object and the speed necessary for real-time application. So evolution of YOLO has over the years, which each version bringing in improvement in accuracy, speed, and handling complex scenarios. We are now at the YOLOv11, So there is so many of versions. They are started from the version 1. Now we are in the presently YOLO V11 with lot of improvement, which continues to push up the boundaries of object detection capabilities. So what's new in YOLO V11? So in here, improved feature extraction with advanced backbone. YOLO V11 leverages a more sophisticated backbone architecture for feature extraction, allowing it to detect and recognize objects with a greater accuracy even in complex or cluttered environment. With the optimization in the both network architecture and the processing pipelines, YOLO V11 delivers the faster interface times, making it ideal for real-time applications such as autonomous driving or a live video surveillance. So it also have the faster interface speed, enhanced scalability and diverse dataset. YOLO V11 is designed to handle a wider variety of datasets, scaling efficiently to work with the different images and the image sizes and object types. This makes it more versatile across various domains, and from medical imaging to the large scale video analysis, we can do lot many of things. These advances contribute to the YOLO V11 ability to achieve the state of art performance in real time object detection tasks. So we required some of the prerequisites before setting up the environment for the object detection model. So before you can start working with YOLO V11, you will need to set up the right environment with the required libraries. So first library that we have to require is the PyTorch, a popular deep learning framework that YOLO V11 relies on for model training and the interfaces. Second library that we require is a Torch Vision, a library that provides access to datasets and pre-trained models and image transformation tools essential for working with YOLO V11. And the most important library that we required is Ultralytics. This is the library developed by the creators of YOLO, providing easy access to YOLO V11 model training scripts utilized for running detection tasks. So to set up the environment, you can install the necessary libraries using the following command: pip install torch vision ultralytics. Once installed, you will be ready to start training and deploying the V11 model for object detection tasks. So here I am using the Anaconda. So I have set up the environment using Anaconda YOLO VNV that I named here. So this is what I used for setting up the environment. Okay. So loading the YOLO V11 model. To get started with the YOLO V11, you can load pre-trained model which save your time and computational resources. So here how you can load the V11 model using the Ultralytics library. So you have to code the Python from Ultralytics import YOLO. So from the Ultralytics, the YOLO will be import. Then the model equal to YOLO YOLOv11.pt. So from by using this command, you can save your model and you can use it. So it will save a lot many of time and resources, because for training the model it will require lot many of time. Okay, see, it is depends upon the how much size of data set you have. Okay, so train on large data set like Coco, we can also use Coco. So how can we prepare the test image? Before performing the object detection, you need to load and visualize the test image. This allows you to confirm that the image is loaded correctly before feeding into the YOLOv11 model. So here's how I shown that how can we load and display the image using Python. From PIL import image, so there is a given the image path of the test image. Okay, then img.show, so it will display the image. Okay, so PIL is the library is used to open and manipulate the images in Python. In this example, it is used to load an image from specified path and display it. Running interfaces. Once you have prepared the test image, the next step is to perform object detection using YOLOv11 model. This is done by passing the image to the model, which will identify and locate the object in the image, whatever that you want to detect the object from any images. Here's how you can run the interfaces by just giving the code result equal to model and the in between the image path. So it will be perform object detection on the image. Model image path command runs the YOLOv11 model on the input images and perform the object detection. The model will output a detected object including their location and the confidence scores. So how can we understand our output? So you need to understand the interface run by the YOLOv11. The object consists of several important components that provide information about the detected object. It will show as a bounded boxes. These are the coordinates that define the location of detection object in the image. Its format typically use XY. XY is a top left and the bottom right corners, specifying where the each object is located. Okay, so you can extract and print the R result. You can use the following code for result in result print dot boxes xy. It is for coordinates the bounding boxes. Second print is the print result dot boxes dot config. This is a confidence score. Third, we can print result dot boxes dot cls. So it will print the class labels indices of the object classes. So this is how we can understand the image output by YOLOv11. So if we talk about the applications of YOLOv11, so it is so widely used. YOLOv11 speed and accuracy make it powerful tool for a variety of industries. Some of the key sectors that benefit from YOLOv11 includes smart surveillance. So you know that what is the surveillance? YOLOv11 can be used in security systems for real-time object detection, such as identifying people or the vehicles or the suspicious activity in the surveillance footage. Healthcare imaging. In the medical field, YOLOv11 helps in analyzing medical images such as detecting tumors in the X-ray or identifying any abnormalities in MRI scan and aiding in quicker diagnosis. Also in retail analytics, retailers can use YOLOv11 for monitoring store sales, tracking inventory levels, or analyzing customer behavior in a store, providing valuable insight into the shopping patterns or the operational efficiency. There is some of autonomous systems that we require the computer vision, just like it is plays a crucial role in autonomous driving and robotics, where it helps vehicles or robot detect obstacles, okay, and other essential objects for safe navigation. So these are the impact of YOLOv11 and also the advantages in these industries and its ability to deliver real-time insight and automation. By quickly processing visual data, YOLOv11 enables system to make the immediately decisions, and that decision is to be used by many industries for enhancing their efficiency and accuracy and overall performance by applying it. So the conclusion I will cover later on. Firstly, I'll show the R model, how I given dataset I train on my dataset, and what will be the R object for object detection. Okay, so firstly I'll show the folder that I have the test images. Test images, these are that will be the test on these images. So the dataset I have that I trained to the model, this is a license plate dataset. Okay, see there is images, lot many of images of vehicles. See, these are the images. There is lot many of images we have of vehicles showing the number plates. So our objective is what? So we will give the unseen data just like any image. Our model will detect the number plate. Okay, these are data set, lot many of images we have. So but with regards of images we have some labels, so it is required labels. So every images have their own labels. So the labels we can create for your own data set that you customize your model to train on specific data set or the images. You need the labels. You can create these labels by label mg, so it will create the labels. Okay, now comes to the R model. Okay, so firstly I import the sys print sys version because there is a prerequisite there. The python we required for it is a 3.10.16. okay, so that's why we set up the environment for particular versions of R, what are the libraries we will use. Then you have to pip install torch vision, torch audio, index url. This is, so actually I already imported it, so it's showing requirement already satisfied. Okay, then you need to install Alterytics. By following command pip install Alterytics, you can install the Alterytics in your system in the environment. So it is also already satisfied, it's showing because already I downloaded it. Next, so all after downloading all necessary libraries, we will just import that libraries. From Alterytics, import YOLO. Second library is for matplotlib to visualize the graph images, and import Seaborn as SNS. It is also required for visualization for better representation of visuals. Then you have to import the cv2 and the numpy. So model equal to YOLO11 n.pt. This is the I loaded the model. Then you have to train the model. So for train I given here the epochs of 5. You can adjust, you can increase your epochs according to your training data set and the accuracy. The image size that I giving here is 400, the training image size. Device 0, this is a device 0. For the device you can give the 0 1 2 3 or the device for CPU. Okay, so after running this, firstly we have to run this also. It will take some time to install and import the libraries. Okay, it's showing required already satisfied. Okay, it is also run. Okay, so I will not run this model again because it will take lot many of time, so many hours it will actually already took. So I just run and trained our my model, and I saved it. So I directly import from. So see, these are my model. I save it. So the model will save in your YOLOv11 folder. Okay, in the runs folder, detect, and these are the model that already I run earlier, predict and predict 2. So the multiple time you run the model, it will save in this folder, in another folder. Okay, in the train itself. See, so now I'll just show the prediction how our model is working. Okay, by training the data set. So I run here. See, the test images is showing the license plate here. So it is object, the other object is license plate. It is detecting from the images. You can see it. 0.73, it is a confidence score it is showing for this object detection. So this is how you can work on the images and the videos. If you want to work on the images, images or the videos, you can give to the your model. So I'll show you the video also. See, these are the videos. So there is a vehicle is moving. Still, I want to detect the number plates of it of this video. So in my model, you can see. Okay, these are the accuracy that are graphically I'm showing. Okay. So see, in the taste video folder, there is a videos. So I feed into the model and save equal to true. Just I want to save that video by object or detected a video. Okay. So it will run. It will take some time. So it will extract from the frame and detect our object. I can show from itself here. It is saved in the taste image, in the runs, detect, predict 4. So predict 3, I think, in the video. Okay, here itself. See, the license plate is detecting from the video. So this is how it works. You can give your own images or the videos. So before you have to train your data set, but by giving the labels also. So if you want to create the labels for particular image, you can use a label mg. It is an encoder. This creates the labels. Okay, so now comes to the conclusion. To wrap up the today's session, let's quickly I'll review the key points that we covered. First, we talk about the YOLOv11 advancement, discuss how YOLOv11 has evolved, highlighting its improved features, extraction, and the faster interface speed and a better scalability for the diverse dataset. Also, we covered the hands-on interface demonstration. We walked through the practical demonstration where we loaded the test image, ran YOLOv11 object detection, and analyzed the output to understand the bounding boxes and the classes, labels, and the confidence score. So there is challenges for the participants. As a practical exercise, I encourage you to use your own image detection. Try applying YOLOv11 to the new image and run the object detection process yourself. Analyze the output, look the bounding boxes, confidence score, and class labels, and analyze how well YOLOv11 detects the object in your image. Okay, so this will help you to solidify your understanding and gain hands-on experience with the YOLOv11 in real-world scenarios. Okay, thank you so much.